Thank you so much. It's a pleasure to be with all of you. I'm going to put up some slides for us all to just ground our conversation a bit. And as I do, I'll just introduce that my plan here is to make you aware of a few cybersecurity threats and try to sort of demystify a little bit what cyber means when it comes to nuclear security. So when we think about nuclear security here, I'm most focused on, of course, nuclear weapons where they are held around the world, but also any place there is nuclear materials or a facility that hosts them or uses them. So even in a nuclear energy plant. A lot of what I'm going to talk about regarding cybersecurity, though, applies to any sort of critical infrastructure that you may have at home in your country. We've seen similar incidents to what I'm going to refer to today at a number of different establishments, be they water filtration plants or really any sorts of critical infrastructure you can imagine. So the three things I would really like to communicate to you today are here. First, the cyber threat to nuclear facilities, it's real and it's urgent. For a long time, there was questions about whether or not these were really real, whether or not it could really happen, that some sort of cybersecurity incident could actually impact a nuclear facility, but it certainly can. And I'll talk a little bit more about why there was a little bit of that debate, but I'll try to make the case so that you walk out of this conversation realizing and can continue to make others aware of this issue as well. Regulations around the world that should be sort of protecting against these items are falling short. My organization, the Nuclear Threat Initiative, as I think you're going to hear or have already heard about from some of my colleagues, tracks on a biannual, every 2 years basis, the regulations for nuclear security around the world. And what we found is that specifically on cybersecurity, we still have a lot of work to do. Third, there are important ways that we can and cannot prioritize so that we can minimize and manage cyber threats to these facilities. There are a number of ways to do this. Oh, I'm sorry, that's my daughter. She's downstairs. She's young. There are a number of ways that we can work on these threats, even if we are not the ones in the facilities trying to manage and mitigate them. So how can a cyber attack compromise nuclear security? First, we think about there are 4 items here that we need to be conscious of. First is the most obvious, perhaps. We don't want to use a cyber means to steal nuclear materials. That could be any type of fissile material. It could be any sorts of uranium, any sorts of plutonium, anything that could turn into something usable, as I said before, either for nuclear energy purposes or potentially to be weaponized. We're also worried about triggering some sort of radiological release, some sort of issue at a nuclear power plant or a nuclear research facility that could impact people, individual citizens living nearby. So you can think of the Fukushima disaster, for example. That was not cyber mediated, but it did trigger a radiological release that had dramatic impact on the local population. We also are worried about undermining trust in the military systems that include nuclear weapons. I could talk a lot more about that in the United States' context, but in particular, we're worried that those who do have nuclear weapons should, certainly there's a whole set of policy questions around whether or not they should continue to have them and how they can remain safe. But specifically to cybersecurity, we're concerned that those who have them need to be able to manage, monitor, and protect and secure them in any number of ways. And as more weapon systems use more digital components, we need to make sure that those in leadership have the ability to remain in control of those weapons. Finally, we're concerned also about information. We're concerned about trust in critical information and the integrity of the data. If you receive an email and you don't recognize the sender, a good cybersecurity practice is to be cautious when you open it and to perhaps not click on any of the links that are within the body of that email, right? There are some tricks that you might yourself employ to make sure that you can trust both the sender, trust the content, and make sure that as you open that email or you do something with the attachments, that you are not putting sort of additional risk onto your computer and your digital systems. And so here we're worried that the information, critical information, something that could relate to the management of a nuclear power plant, for example, a schematic of how the plant is organized, who works there, those types of data are protected and can be trusted by the owners and leaders. I talked a little bit about how for a while there was a myth out there that nuclear security did not intersect with cybersecurity. That is false. A lot of folks were thinking in the past that if their digital device, their cell phone or mobile phone, were somehow isolated from the controls of a nuclear power plant or another critical infrastructure facility, that they didn't need to worry about cybersecurity. But there are any number of ways that a digital attack could create havoc or disrupt something in that piece of critical infrastructure. So in principle, of course, isolating networks is good, but it's rare in practice. There are very few organizations around the world that operate critical infrastructure that don't have some device that has a port for a USB or an ability for someone via the internet or for someone in the facility with access to actually connect to that. There's these networks tend to be very complicated. I'm sorry, she just keeps playing and screaming. And they are very difficult to disconnect from one another. So being an island, as some folks have discussed in the past, disconnected from the internet, it's not enough to defend against a determined adversary. In fact, there is a reported incident against the Iranian nuclear weapons program between the United States and Israel potentially, that in fact used, that was able to sort of impact the enrichment of uranium without connecting to the internet. So the air gap myth is in fact a myth. And offensive cyber activities are really increasingly problematic. So you can see on this screen the number of states sponsored. So this is a government around the world attacking another either civilian owned or government owned facility or system has really risen exponentially, and it's expected to continue. Regulations around the world fall short. I mentioned the Nuclear Security Index. Here in the blue boxes across the map here, you can see those countries that have nuclear facilities. We're only measuring nuclear facilities here. So if it's in gray, we didn't ask the question. But you can see that the lighter blue is not good. Lighter blue and light blue is an area where there needs to be a lot more work put in from a regulatory perspective to improve the cybersecurity of nuclear facilities. And what should those regulations look like? This is an array of some of the things that we promote and that we call various organizations around the world to manage. So you need to have a plan in place. You need to be required in the first place to protect your facility against against cyber attack or digital attack. You need to protect any sensitive digital asset that connects to the safety systems, the security systems, anything that could potentially lead to something going wrong. Any sensitive digital asset needs to be protected. When you plan for how you guard your facility, it's important to make sure that your plans include cyber threat assessments. And I could go further. Perhaps the most important, and this is true no matter what facility you work in, whether it be a nuclear facility or not, a cybersecurity awareness program that truly reaches all personnel with access to any of the important digital systems. And again, because so many systems in most organizations are really interconnected, it's important that everyone who has the potential to touch or interact or engage with those systems, anyone who has a login, needs to have some sort of cybersecurity awareness, starting with the really simple stuff like I described in terms of checking and being very cautious when you receive an email that you're not expecting or from someone that you might not trust initially. So lots of work to be done there, just in terms of building awareness, and then of course building the metrics and the programs around that. All of us as employees, no matter where we work, have a certain responsibility with this. So I'll just briefly outline a couple of priorities that we advise nuclear facilities or those who regulate nuclear facilities to focus on, and those who manage any facility, again, a critical infrastructure facility or not. A few things to call out here in particular. So for operators of these facilities, it's really, and I started to talk about this when we think about awareness. Awareness is really just the first step. We need to have processes and culture to embed cybersecurity efforts and work into the day-to-day operations of these facilities. There needs to be certain processes and checks and protocols that help the employees do the right thing when they see something that could be potentially suspicious, or even if they don't have, if they are unaware that it is suspicious, that there be some sort of protocol in place, something to help out the individuals trying to do the right thing here. And then finally, if you already are or will be a government official or regulator, it's important, and throughout sort of the academic community as well, this is also true, we really need to increase the quality and the number of cyber nuclear experts around the world. There are lots of folks who focus on cyber. Some of them focus on cybersecurity for critical infrastructure. There are very few who focus on both cybersecurity and nuclear security or nuclear operations. And so one initiative at my organization is trying to bring together the experts that are working in this field and helping them learn best practices from one another, and then eventually helping them sort of train and provide opportunities for others who want to work in the field and who can do more here. So that's my brief introduction of cybersecurity in nuclear facilities. I would love to entertain some of your questions. I'll leave it to the moderator to guide us on the right way to do that. But thank you for the opportunity to chat with you, and I look forward to hearing your questions and learning a bit from you.
Thank you so much, Erin, for your great presentation. Learned a lot. Especially about making sure you are careful about the links that you're clicking when it comes to emails. It's even like some emails that look like they're from a reputable company. We had a cybersecurity class in which they spoke about in Ukraine when the Ukrainian power grid went down. And it was, once he clicked the link, there was nothing he could do to kind of go back from there. We will hold the questions until the end, though they are starting to populate. But with that, I'm going to hand this on over to Mr. Robert Shaw. He will be discussing with us some of the interesting things that he's been working on. Mr. Shaw, the floor is yours.
All right, thank you, Rayna, and hello, everyone. It's an honor to be able to participate and contribute to this workshop in this session. I'm going to go ahead and share my screen. My topic is on emerging technologies and non-proliferation, and specifically a case study on 3D printing as one of the emerging technologies that is attracting attention in the WMD non-proliferation policy space. So one moment here while I hopefully bring up the presentation. And here we go. So 3D printing is also referred to as additive manufacturing. And I'll be walking us through first a very brief introduction of the technology. I think many of you here are maybe familiar with 3D printing, may have worked with 3D printing in some capacity, but I'll provide a basic introduction here at the outset, and then move right into sort of where the technology is today and how that is developing, and in those areas that are of interest for those focused on non-proliferation of weapons of mass destruction and international security. At the same time, I will be highlighting some of the benefits of 3D printing that are seen both from a commercial and economic perspective, as well as a human welfare perspective. And as a case study for emerging technologies, 3D printing really sort of emphasizes the need to maintain this balance between the benefits for economic development and human welfare versus the challenges that such technologies may pose for non-proliferation efforts. So with that, just first a very basic introduction. Again, for many of you, this may be familiar, but just so that we're all sort of on the same page when when I'm using the term 3D printing. Typically, a 3D printer will involve a device that has something called a print nozzle that can move around, and through the print nozzle, either a plastic resin in a liquid form or a metallic powder, a metal in a powder form, is injected through the nozzle onto a surface. But as it's injected onto the surface, it is heated typically with a laser to where the liquid resin solidifies very quickly, where the metal powder sort of fuses, and through this process, a sort of layered object can be created, in effect printed. And a key component here is not so much the nozzle or the surface or the laser. Certainly those are key components, but behind all of this, there is, this is all driven, through sort of computer-aided design. So typically there is a computer-aided design or a CAD file and software that's being used to drive the printer so that it follows the design in the computer-aided design file and will produce the object in the design. So the design file is as much a key component of this as the printer itself. Now we're at the sort of let's call it the consumer level, the hobbyist level. 3D printers are already sort of widely used and enjoyed. Here we have a very common one, an off-the-shelf model. It's a MakerBot replicator, and this is something that can somebody can have on their desk or in their garage, and typically you'll use plastic resins and you can create very basic objects, and as shown in the photo here. Although some off-the-shelf printers for individual consumers also use metals. This is a keychain ornament that I may have lost the screen share. One moment. Apologies for that. Okay, hopefully we're back. This is a keychain ornament that's made with stainless steel, so the use of metals, in the hobby market, let's say, is already quite common. And at the individual level, I hesitate to use the term hobbyist here, but we've unfortunately have seen 3D printing used also in the creation of weapons. This is a 3D printed handgun that was produced using an off-the-shelf, very basic 3D printer. It's made entirely of plastic, but this handgun can fire a real bullet. This was developed by an enthusiast group that collects handguns, but this has raised a number of alarms because the design file that was used to produce this handgun was made widely available on the internet and can be used with a variety of off-the-shelf 3D printers. So already 3D printing sort of raised concerns in the security arena at the sort of individual and hobbyist level. But 3D printing is also used in the industrial manufacturing space. And what we see here is an industrial level 3D printer, that uses metals. This is produced by a company called Concept Laser, based in Germany. They're a subsidiary of General Electric. And these devices are used in a wide variety of industries, but particularly in the aerospace sector. And speaking of aerospace, here we have an example of the types of items that today can be produced through industrial 3D printing. And this is a fuel nozzle that was produced by General Electric for use in its new LEAP engines. It's much more efficient, supports fuel efficiency, and in this sense, great welfare gained through reducing emissions, reducing fuel usage, better for the environment. We can also see here, this is a very sophisticated, complex metal shape. This fuel nozzle, the image to the left, was entirely produced through a 3D printer. It's really remarkable when we consider just the level of kind of detail and the complexity in the design of that device. And so this has raised also, though, some concerns about dual use, the possibility that 3D printing may be a new way to manufacture dual use items, that a new manufacturing path to these that while having a commercial or civilian benefit could also raise security concerns. And so, here's an example. This is a drone. It's produced by an aerospace company. And I would say close to 100% of this drone is 3D printing, not 3D printed, not completely, but close to it. This is, the company that produced this is a defense contractor. So the drone may also have a military dimension as well. But what's novel here is not so much the drone, but the manufacturing path to it. So, so I want to now cover some of the most recent developments, particularly in industrial 3D printing. And here the term that we hear used is additive manufacturing. That's the term most commonly used in industry. And so the focus presently has been on new materials that are optimized for additive manufacturing, optimized for 3D printing. This includes new types of steel, and also 3D printing has successfully been used to produce aluminum alloys that are commonly used in the nuclear sector, as well as some very complex, but also materials with high strength, such as a bulk metallic glass. These are developments that have just occurred really in the past 2 to 3 years, but it's striking just how far the technology has moved, particularly related to the materials used. There are specifically 3D printing has already been used in some nuclear applications. Mainly, it's been used to produce parts that are no longer manufactured. For example, in an old or aging reactor, where the original supplier of the part may no longer be producing it, 3D printing has been used to kind of successfully reproduce that part. And so in the upper sort of right corner here, there are impellers that were reverse engineered by Siemens using 3D printing. These were impellers that were used, in a nuclear power facility. 3D printing is even being used in the realm of nuclear fuels, thorium dioxide. There's a team in Canada that's experimenting with using 3D printing to produce at least thorium dioxide in a form that might be suitable for a nuclear reactor. What's also generating concern in the non-proliferation space, although again, I should emphasize that this is dual use, there are benefits as well, is the use of 3D printers to in the area of satellite launch vehicles or rockets. What is featured here is a startup company. It's based in the United States, I believe in the New York City area. This is and the photo here depicts the company. It's basically 4 individuals who have designed a satellite launch vehicle, a rocket, that is designed to be entirely 3D printed. And so they've created the design, and their plan is to use a German 3D printing services company to produce the rocket. And the goal is to actually launch a satellite into low Earth orbit using this entirely 3D printed rocket. There's another company called Relativity that has developed, and this is developed its own 3D printers. And this is what we see on the left. These sort of robot-looking devices, and their goal is very similar, to produce a sort of full rocket using 3D printers. Again, this is for the commercial space industry, but the concern is if you can produce a satellite launch vehicle for the commercial space industry, potentially you could also produce a missile, through these means. So 3D printing is also intersecting with other technologies, other emerging technologies, particularly artificial intelligence and machine learning. And so the effort here is there's been an effort to incorporate machine learning into the design process so that rather than, let's say, a person, an engineer developing the computer-aided design, rather and a machine learning artificial intelligence program would create the design based on some general parameters that would be provided. And so it's in effect a machine learning program, an AI program that's creating the design that then uses the 3D printer. And it's been the experimentation has been fascinating in this area. What we see here is an engine block that has been produced through this process. This design was created entirely through sort of a machine learning AI program. This was not a human design per se, although a human entered parameters for this. And we can see a very efficient use of metals, but also some rather strange sort of forms or a form factor. And another example of this, here we see an experimental automobile chassis that's created in the same way, where an AI program kind of designed this, and then it was 3D printed. And so we see this really interesting automobile chassis that, again, you can see it's sort of emphasizing efficient use and placement of the materials, but probably something that a human might not necessarily sort of design. The industry has really developed in recent years. There's a leading trade show held annually in Germany that focuses specifically on additive manufacturing, the 3D printing industry. At this trade show, aerospace and the automotive industries are heavily represented, and 3D printers, 3D printing services for these industries will sort of feature their products, feature their printers, feature their services. I attended this trade show a couple of years ago, and we see certainly the aerospace sector has been a leading adopter of additive manufacturing, and in some novel ways. Here we see the 3D printing being used to produce or at least assist in the production of what are known as CubeSats. These are very small, lightweight satellites, tiny satellites, and these are produced using sort of an experimental polymer designed to be used with 3D printers. And the company here, Orion, is working with this experimental polymer. Also, the area of electronics and circuit design and additive manufacturing are rapidly sort of coming together to where a 3D printer, in addition to printing a shape using metals, can also embed electronics into what's being printed, to where potentially the need for circuit boards and so forth may be reduced, to where the electronics is embedded within the materials that are being 3D printed, which could lead to some very novel products and new industrial applications. There's a whole supply chain surrounding this, and that was featured at the trade show. And the photo on the right sort of shows these are all the different powders that are used, metal powders that are available for use. Among some of the concerns are the fact that miraging steel powder is now available for 3D printing, and this is a material highly suitable for the manufacture of uranium enrichment centrifuges, for example. So certainly there are dual use concerns surrounding the overall supply chain for additive manufacturing. So to conclude, the question here then is, what are the proliferation risks in 3D printing? Presently, and I think this is something very important to keep in mind, is that there is today no evidence that 3D printing has been used to produce a weapon of mass destruction, at least in the traditional sense, a nuclear device or a missile, intended as a delivery system for a weapon of mass destruction. So this is very important to keep in mind. This is an emerging technology, but it is entering the industrial supply chain. The first sort of risk area that is seen is that this may be an alternate way for a proliferator to acquire dual use items. It's sort of an alternate manufacturing path, another way to produce them. And when you have a new manufacturing path, that may present challenges for traditional systems of sort of control or trying to prevent proliferation. Additionally, though, beyond simply the production, let's say, of a missile or WMD, there's the concern, a risk area too, is that 3D printing, additive manufacturing may be beneficial also for producing very quickly the infrastructure surrounding a covert WMD program. So a photo on the lower left is an award-winning design of an outdoor structure that it would be entirely printed, entirely 3D printed. This was developed by a team of university students, graduate students at the University of Tennessee, I believe, and this is sort of an outdoor sort of a structure. But the dual use applications are certainly there. Is that in theory, the buildings and so forth that would be needed for, let's say, a covert site could be produced potentially quickly and in remote locations. And then the third risk area is sort of the unknown. When we begin to see the wide range of materials used with 3D printers, the fact that electronics can be embedded into designs, the fact that artificial intelligence is being used in the design process, there is the question of whether something truly disruptive and new in the sort of weapons or defense space might be created, presenting sort of a new proliferation risk altogether. Very speculative, but it's just the pace of developments and the potential for really new designs sort of raises this question. I should emphasize, though, that there's not really a strategy at this point, or a very clear strategy for controlling the additive manufacturing. And it's important to keep in mind the benefits as well. Currently, and this is what brings me to the issue, is that export control policy is very closely looking at this technology, and the multilateral export control regimes, such as the Nuclear Suppliers Group, are really sort of taking a close look at this and considering, how best to manage the security risks while allowing for the commercial benefits of 3D printing to be realized. And so I'll conclude here with a highlight of these benefits, something that we need to keep in mind. Just last year, 3D printing was used to address an urgent situation in Italy related to COVID-19. Respirators at Italian hospitals were breaking down, and there was difficulty in getting replacement parts, particularly respiratory valves used in the respirators. And so what we see here are 3D printed respiratory valves. There was a team of sort of 3D printing experts and enthusiasts that came together, sort of organized, and very quickly were able to produce these valves and get them into the hospital settings to support sort of the health challenges related to COVID-19. So this is something I want to just conclude here on, and welcome questions during the Q&A.
Thank you so much, Mr. Shaw. And our final presenter for today is Mr. Dave Schmerler. He will be discussing what it is that he does out at CNS in Washington, D.C. And I will also actually be adding a little bit to the portion on the 3D modeling towards the end of his presentation. So with that, Dave, it's all yours.
Thank you. All right, let's share screen here. All right. Can everyone see my screen? Yep, great. Okay. So one of the things I'm going to be talking about, or I guess like a series of things, are how we use what in CNS we refer to in-house as new tools, things you might think of them as are just emerging technologies and other new research mediums that are accessible, or mostly, but almost in its entirety, to varying degrees accessible to people who work outside of the government, but used to be domains that were almost exclusively in the government. So how can the open source or public and academic research community replicate impressive or valuable research and create insight into things that we at one point in time, or I guess maybe even 10 to 15 years ago, weren't able to interact with. So the first thing we're going to talk about, or I guess in the series of lists, are image forensics, how to leverage social media for the research that we're doing, the use of satellite imagery, the different types of satellite imagery that we have access to, and how to manipulate and take advantage of that. And then the last section, which we'll be sharing, is 3D modeling, its uses for verification, analysis, and then education and outreach. So the first thing is image forensics. Image forensics are essentially a field and a series of tools that allow you to not just look at a photo and enhance and try to study exact details, but look at the information beyond the photo. So a photo is a bunch of pixels. The pixels are made up of numbers, and in those numbers are things that aren't necessarily directly related to the image that you're seeing. So if you take a photo with a digital camera, you'll notice that the file size is generally pretty big. And if you save it on a Lucy type compression file type, so something like a JPEG, the file size will get smaller and smaller, yet we're not really losing what the image is. So what is that data in the image that we're losing, and how can we use it to verify the authenticity of an image? So this is maybe a bit more of an expensive example, but these tools do exist in varying degrees for free online. We were learning how to use, in our Monterey office, a French software called Tungsten. And what Tungsten does is it looks at an image from a whole bunch of different levels to try to figure out what exists in an authentic image in unique circumstances. And if it's missing, can we, one, verify the authenticity of an image, whether or not it's original or not? Two, can we figure out what's missing that should be there, or can we just dismiss the image for analytical purposes? And here is Roger, the creator, on the right, and then Catherine Dill and I on the left, learning how to try to understand what his software is doing. One of my favorite filters, which I always talk about, is a filter called IsoCleans. And I like this one a lot because I look at pictures of rockets and missiles being tested all the time. Roger showed us this filter. He said that if you take a photo and it's directly from the source and you have a hot heat source in the image, you can use this filter to see what essentially would be wavelets, or the way light interacts around hot objects, because it moves around gases moving differently than it would around an object without heat. And in this image right here, we can see, actually I'm going to shrink that for the sake of showing. Oh, wait. You can see that here, I took a photo with a lighter in my office, and I wanted to see if I could replicate some of the results he was talking about, because this was straight from my phone. And when you magnify the tip of this lighter, or of the flame, under the IsoCleans filter, we can see that while it's not visible necessarily in just the optical image, that the filter does pick up these little wavelets that go around the kind of tip of the flame, because the way that light is passing through the air around that flame is different. So that is applicable for the study of missiles. If we get images from, say, North Korea or Iran, they say we tested a missile and here's a video or a picture, that we want to verify the authenticity of that image, because the Iranians especially, and the North Koreans, have fabricated test imagery before, especially in the past. Now not so much. We can run this on an image from Iran of a surface-to-air missile test. Now, much like the lighter, if we run the IsoClean filters over it, we should expect to see the same type of wavelets around it. So when we run the IsoClean filter, we can see that anomaly that's not visible in the image, but does exist in the data in the image, is still there. So how would you fake this? Well, if this missile were copy and pasted into this image, now, of course, there are a suite of analytical tools in photo forensic software that you can use. This one is just one specific example. You would see that there would be no wavelets around here, because the way light is passing around or through this exhaust is non-organic to an image if it were just copy and pasted in. So we run this to a more famous example that the North Koreans gave us from one of their first, I think, if not their first SLBM tests that they shared imagery with us of. And it's Kim pointing and someone else pointing at the missile as it emerges from the water. We have the smoke, we have a missile. It looks a bit grainy, but if it's like the Iranian photo, we should expect to see these wavelets around the exhaust, because this is a very hot heat source and light's gonna be passing through it differently. We run the IsoCleans filter, and we can see that there are some wavelets around here, but in general, the image looks kind of funky. There's nothing happening around the heat source in the image, but there are wavelets happening down here. In the series of videos that we got from the North Koreans from this test, we never quite got this exact scene, but we did get a picture of the missile going up and then dropping for a split of a frame, and then cutting to what was obviously a CGI cut of it soaring through a very poorly rendered sky that they had just thrown together. So I think, first of all, we can use the photo forensic software to determine that this image, in regards to what we're seeing with the missile, is not necessarily organic or original. It seems to be manipulated to a certain extent, where we have a lot of partial wavelets happening down here and not up here. When you first test an SLBM, you launch it from underwater barge after you do all the dry or shore testing to make sure the thing works ideally, and then you move it into water testing. I think that Kim was observing an ejection test from underwater. So the missile did come out, it did ignite, and it probably happened around here. And then it plopped back in the water, because that's generally how the series of missile testing happens for an SLBM program. So this is a really good example of the image forensic software detecting a thing that probably did happen, but the North Koreans changed it to reflect much more success, or to a varying degree of extent of the test that actually occurred. So if you want to see for comparison, this is what it should look like, where the exhaust does have these like wavelets contouring around the exhaust here. And in the North Korean example, we didn't get any of that. In fact, there was nothing around this optical heat source whatsoever. So it's either manipulated, or the entire event was fabricated. I'm more partial to the side that it was manipulated. Another really interesting, fun tool for people to use when things are happening related to proliferation or just in general any WMD research is social media. Whenever certain countries test missiles, they often will record videos of them and post them online for propaganda purposes to show that they're making a success and whatnot. This is a video from Yemen of Houthis launching a missile that was either designed, manufactured, or to the latest extent assembled in Yemen to fire against Saudi Arabia. So when you fire these missiles at someone, especially at a country that has a lot of digital development, however you want to define that, essentially access to cell phones and apps that allow you to post videos online, you would think if missiles were landing in that city that people would record them. Often, even when there's like a small accident or something funny or cute happens, we pull out our video first and record it. Well, if missiles are landing all around you, you would think you would want to seek cover, but people also generally just stand there in awe and point their camera at the event. So after this had happened, we got this video later. Jeffrey and a few other colleagues and I went online to figure out how we could get video confirmation that missiles were actually going towards Riyadh. Maybe not landing, but at least the missile defense systems were going off. So we went to Snapchat, which is a great app for this, which has a heat map. So if you Google Snapchat heat map, you can figure out who's posting what general areas have the most posts, and depending on what's happening, they'll even post videos live as they're happening. So for this one, during the day of that test, we were looking to see if anyone in Riyadh was posting videos of this missile strike happening, or at least the missile defense systems going off, to verify the news stories that we were hearing. And it turns out that all across Riyadh, people were posting videos of debris hitting the streets. And there were a couple of mishaps with the missile defense systems themselves that I'm sure the Saudis weren't necessarily excited about, but it does happen. No system is perfect. So we can see these videos of missile defense systems going off to intercept the missile coming in from Yemen. We can see some of them blowing up prematurely, and one of them actually went up, made a U-turn, and then struck the ground near where the missile defense system was. And these were all things we were able to do almost live as it was happening, using social media apps to verify events happening around the world, especially when they're related to WMD. Beyond basic satellite imagery analysis and geolocation, which is a skill that has really kind of proliferated, if you would, across various fields, which essentially is taking an image like this, trying to figure out where it is using satellite imagery. We're using different bands of satellite imagery to analyze things that are happening at sites related to WMD production and potentially proliferation. This is an image from a North Korean solid fuel test. I believe it is the only test that we have ground imagery of, not the only image, but the only test in its single event. This is just southeast of the city of Hamhung. And we were trying to figure out how can we verify these events are happening when we don't necessarily get lucky enough to get an image of the test happening, because we only get a satellite image of a certain location, or we used to, I'll talk about this a bit later, at a specific point in time. So just because we don't see anything happening at the one moment a picture was taken doesn't mean activity is happening. So how do we try to understand whether or not sites are active using pre and post test information if that event is happening? Well, it turns out that when you take a satellite image, you often get more than just your three bands. Your three bands that give you an image that would be just something you would see on Google Earth. There is a fourth band and the thing in between that gives you what would be called near infrared, which gives you an indication as to vegetation health. Things that are leafy and green and organic and are healthy, they come off as being bright red. We can see that right here by these trees. Things that are leafy, greenish, and not necessarily healthy or abundant, we have in these fields right here. So if we have a engine test stand, like in the North Korean example here, you've got a bunch of heat and exhaust. Well, this vegetation will be fine on this side. If there's any vegetation opposite of this heat source, it's probably going to get scorched, burn, or die. So using the fourth band, the near infrared band, we're able to analyze vegetation health, which might not seem applicable to our research, but allows us to see whether or not the North Koreans are lighting a huge fire opposite of their engine test stand or motor test stand, which they are in this example. So in this example, we've got pre and post test data, which is not easy to see in your standard satellite imagery, but using the near infrared band, we can see at this angle that there is a noticeable change opposite of the test stand. For reference, this test stand right here is that little block, the trench extending this way. If we zoom in to see that change again, here's the engine test stand that we saw. The image was taken from this direction. This is where we would expect to see the vegetation die off after a test. And then after an event that we didn't quite pick up on, what we heard reported in the news, we ran the near infrared band. And you can see that all this red, healthy vegetation is now gone. That's also specifically gone and not really gone anywhere else. So this would indicate that there was a test in between these two dates. And this is a really interesting use of that fourth band in satellite imagery that people like Planet, Airbus, and Max are providing, depending on what satellite imagery you have access to. We can also use this technique to verify missile testing activities at locations. Going back to geolocation, we take an image, we look for cues and reference points to try to figure out where events are happening, because the North Koreans don't really tell us. So we would look at an event like an image like this, we would see roads, fields, hedges, green, something that could be a highway, but it looks way too big compared to another side road. So it turns out this is actually an airfield. So we can use our geolocation skills to reference it to this airfield. We can see the road split off right here, road going off to the side, and the airfield, and the hedgerow, road feeding off to the side, things like that. We even got the same pattern on the runway. Now, to verify that this is not necessarily a fabricated image, but that a test actually happened here, much like the engine test stand, we're going to be looking for areas near this runway that match up where we would see it in the image for dead vegetation, because again, we have a giant explosion propelling a rocket into the air with a lot of heat. So the plants aren't going to quite make it. Using the near infrared band, we can again go in between the dates of the test that were reported, go back to the area that we geolocated it to, and look for damaged vegetation. Turns out you can see exactly where that test happened, because all the vegetation around that launch point, which again we referenced using geolocation skills, is totally scorched. So that is another really interesting use of things that are generally not associated with our field of study, but we can use them to better understand events happening in the field of WMD. Another really interesting development happening with technology and satellite imagery is that we're getting more images of single sites at higher resolutions every day. So instead of getting one image periodically, we're getting images with multiple data that exist beyond the visible band. We're getting multiple images of certain sites every day. And that's only going to increase with time and as more companies kind of proliferate that satellite imagery space realm. And this is an image that we got a few years ago of Kim Jong-un standing in front of a new submarine at the Shimpo South Naval Shipyard, which is kind of the heart of their SLBM program, with the one exemption of NAMPO, which is still a bit undecided, but we're going to talk about that in a few slides. We've been looking at this site for things related to SLBM development. So we look at this site again, and research I did a couple years ago found that they built a new submarine training center at this site right next to where this submarine is being built. So it makes sense you're going to co-locate your submarine training facilities next to where all your big new subs are. But we're not just getting high resolution imagery of these sites expanding, we're getting multiple images of these sites a day. So when the site gets built, how do we know it's active? Well, you generally know it's active in other places where you see cars and things like that, but you're not necessarily going to see that in a small, kind of seaside location near a sensitive submarine base, right? The North Koreans are just going to be marching people around. The people are going to probably live either in this part of the village or these things that could be kind of like dorms or barracks to the right. Well, if we get multiple images at higher resolutions of this site every day, or on certain days, depending on when the tasking falls in, we might be able to see them assembling in the courtyard. And if anyone wants to know what a bunch of North Korean sailors look like at 0.8 meters, we can see that right here. We flipped the image a little bit for the angle of obliquity, so it's the angle the image was taken, but this will be on that side and everything will be flipped around. But here's the courtyard, and here we see a shadow, right? So how do we know this isn't an object? Well, if we look at the other image from later on that day, that material is gone. So maybe that's a blip. Maybe it's material. Maybe they're furbishing the inside, right? Well, if we go to another day and we get another series of shots, again, this one looks a lot less symmetrical. So this looks more like people getting into formation. We go to another image from that same day. Those shapes are gone. So people filing out to get in formation prior to whatever training they're going to receive at this facility, to going inside the facility and using it for the purposes that they're there for. And we can do this again. Nothing. People in formation. So we're getting a bunch of different types of satellite imagery, different bands. We're getting higher resolution satellite imagery, and we're getting multiple images in a single day that allow us to get a sense of the cadence or pace of life at certain sites. So while this submarine that we were previously looking at may not be operational, because I've been looking at this site almost every day for like the past 4 years, so I know it quite well. The academy that they're training people at seems to be rather functional. There seem to be people there practicing. This is or studying at least training to be submariners. And this is something that we're doing with some of the more emerging technologies happening in the field of satellite imagery. And then this is an image of the port on the West Coast in the theme of North Korea's SLBM program. We saw in their last parade that they had displayed a newer, larger SLBM that was in the news. There was a lot of hype around it. Generally of the position that it's important to understand what they're parading, but until they actually test it, let's kind of hold back a bit. There have been, 4 to 5 year stretches where North Koreans will parade a missile and we'll never see it again. There have been missiles that have been paraded for years. They test them, they fail, they develop new systems. So on the SLBM front, it's a bit hard to say what we saw in the parade, but of the locations in North Korea where they could test SLBM technology or missiles, you need a barge before you test it on a submarine. For a longer range ICBM, they're going to want to test it over the country to minimize as much as they can the political pushback for them testing, even though they do leverage or hedge that type of testing technique and have in the past. For something larger, they would want to test it on the West Coast going east to give more range for an ICBM rank class SLBM, or submarine launch ballistic missile. And here we can see that there is a test barge, and the resolution is not that good. I should have zoomed in, but just take my word for it. This is a submarine launched ballistic missile test barge that for the past 2 years has stayed here. And Jeffrey and I have again checked this site almost every day for the past 2 years to see if this thing moves, because if it does move, it means the North Koreans might be refurbishing it or changing it to prepare for an SLBM test. And taking that into context with what the North Koreans said during the parade, what they showed us, we went back to look at this port and be like, hey, maybe they're going to move the barge. And in fact, they moved the barge. It hadn't moved since September of 2018 to a kind of dry fitting location where they might be refurbishing it for testing a larger SLBM. So it doesn't necessarily mean that the test is going to be imminent, but that they could be preparing for the option to do so. And this is one of the benefits of having not just multiple images a day or different types of bands of imagery, but different providers as well, because everyone's going to be taking images of a single location from a different perspective at different times. And this one image right here gave us a really helpful, insightful clue as to what might be happening with North Korea's submarine missile program. And then my kind of favorite new emerging tech that's happening, and it's not quite emerging, but it's emerging in a way that it's more accessible. And I use that, it will definitely be more accessible in the near future, but it's more accessible now compared to where it wasn't accessible in the past couple of years, is using synthetic aperture radar. We went back to the East Coast Submarine Facility again, because it's the site that I study a lot, but we're looking at a satellite image with funny colors, kind of like how we saw that image where everything was red. This actually isn't a photo taken with light. This is a photo taken with a radar. So you can ping down radar at a specific location. The ping will come back, and you can use the, I guess, kind of receptor, if you would, to build something that looks almost identical to a satellite image. The difference, though, is that you get much more precision and resolution. So instead of being like, it looks like something has moved optically, but I can't tell you, using images like this, you can mathematically run equations to determine whether an object is in the exact same place. You can compare multiple images, and you can see where they have moved and when they have moved. Even if it's like, I would compare it to parking a car, driving away and trying to park it in the exact same spot. You could park it in the same parking spot. You can put markers down on the road to try to match up the tires and wheels, but you won't get it exactly in the same location. And synthetic aperture radar will tell that to you. So here's another image from a different angle using synthetic aperture radar. This is the construction hall where that submarine is supposedly being built. And we can see that this right here tells us what we're looking at. So there are no changes. So we're looking at areas with no change. Change occurs often, change occurs seldom over a certain period of time. So using synthetic aperture radar, instead of building an internal repository of where certain things are happening, you can actually run an equation or an algorithm to pull out all the data that you want to know. Where are the busiest locations at this submarine port or the submarine training facility, and what's happening there? So we can zoom in again using that same color code that we have right here, and we can see that, this is a submarine. If you can't make that out, that's what a submarine looks like in synthetic aperture radar. This is a boat. These things are moving seldom, versus this area right here where there's a lot of change happening. So the submarine was here, it moves, goes back. Now for that, it might be because it's in water and it's bouncing around a bit, right? But the coolest thing about this is that we see these little L shapes right here. In optical imagery, something that we would see, I guess, on TV or Google Earth, you can't see through this. This is actually a protective camouflage tarp. It's not necessarily camouflage, but it's black or really dark navy blue, so you can't see through it using optical imagery. But the material itself is made in such a way that the synthetic aperture radar can penetrate it, hit something more solid under it, and then bounce back. So in this image right here, if you were to use optical imagery, you would just see this giant black rectangle. But using synthetic aperture radar, you can see right through it. And here we're getting the pingbacks from metal L beams that have the cover on top. And we can see that there was at one point a submarine under here between those dates, which is just really neat. And again, like there are more companies putting out synthetic aperture radar at varying resolutions and with specific regional coverages. So depending on what you're interested in, you might be able to do that. The math behind and I guess the computer science behind how you interact with SAR data is still very high in the kind of technological educated threshold. So it's not something that I can technically generate on my own, but I know how to look at it and interpret it. And I can work with companies to help process that imagery. So this is something that, again, is just going to be kind of proliferating over time. And then using SAR data, again, we can look at North Korea's nuclear test site. There were rumors that the nuclear cavern created from the test, their last largest nuclear explosion that they did at Punggye-ri, collapsed the mountain a bit. So we can take that formula to do change detection using synthetic aperture radar, and we can see what type of changes there are at the mountain. So we see that there's a lot of movement here because we're getting pingbacks from trees and leaves with different weather conditions. The leaf's never going to be in the same spot at the same time, pretty much whenever it exists, right? But here we can see there's a bit of a pulsing happening. And this pulsing doesn't happen anywhere else. We see a bit of like swaying right here. But at this point, it looks like the mountain's almost breathing. It's because the mountain did shrink a little bit. It got a little bit shorter because the chasm did collapse. So at least that's what we can best determine using synthetic aperture radar. So this is another great tool for monitoring nuclear test sites, if that's something you're interested in. And then last but not least, because you get this type of elevation data and this type of radar data to have an exact model of the location you're looking at, you can take that and then turn those into 3D models. Now, 3D models are great as educational tools, but you can also use them to study sites, because if I turn this model upside down, I can look at where all the general locations of tests have occurred, and I can get a sense of how much space they have to build into this mountain range, which is great. So not only does it help kind of convey the location that North Korea is testing nuclear weapons, it also gives you a general idea of the space that they have to grow if they wanted to. Now, they had a fancy fireworks show where they did decommission their nuclear test site, but to what extent, we're not quite sure yet. And if they wanted to dig that site back up or expand in different avenues under this mountain range, there's certainly plenty of space for them to do so. And then we actually turned that into one step further, a really fun VR walkthrough. So we took images of underground test sites and just kind of had a little bit of artistic liberty with it. And if you want to, you can actually, in a VR headset or a Google Cardboard, walk through the tunnel network under the artistic interpretation of the tunnel network under Mount Montauk. And then going on to, I guess, 3D models, I can pass that on.
So thanks, Dave. So what I do at CNS currently is modeling some of the ballistic missile systems. Most recently was the Jericho system. Jericho is an intercontinental ballistic missile that is Israeli. However, the missile, especially the Jericho 2, was created with the help of the apartheid government in South Africa, where they used technology scientists and engineers from both countries to develop what South Africa would have been used as a space launch vehicle, and that had 3 stages in order to reach orbit. What the Israelis did is they took the missile model and the information and data that they collected there and turned it into a 2-stage intercontinental ballistic missile, an ICBM. And I will share my screen so that you can see some of what, let's see, if I could get access to sharing my screen, please. Here we go.
should be able.
I'm good, thank you.
So,
Okay, so you should see here, this is the Jericho 2. And essentially the program that I use mainly is Blender. It is a free program. I use programs such as Blender for the modeling portion of the projects. There's also another program called SPY, though I use it mainly for ballistic modeling purposes for measurements. It's actually a free program that interior designers use when trying to design spaces within homes and businesses. Another program that is often used is Photoshop, and there's specifically within there a filter called Vanishing Point. Within Vanishing Point, I can use that to measure the length or diameter of a particular object that is important to what I am creating. If you can see here, I was tasked with essentially gathering all of the information that was available. This one here is the Jericho 1 missile. Gathering all the information that was available both in declassified as well as private industry photos of the French missile that this is based off of to create something that could then be tested within our systems. The reason why you want to use a mixture of both visual information as well as documentation is because oftentimes documentation will vary from source to source, but if you can get visual information or photos or videos of the objects that you are looking to model, you can use different tools and different programs to measure it out and to test whether or not the information that has been provided to the public in one way, shape, or form is true to what the schematics are for the missile. I will model essentially everything that I can on the missile. So let me see if I can turn off a few of these. That includes the interior of the missile, both the stage 1, stage 2 of the missile, warhead, as well as the guidance system. Oftentimes with countries' ballistic missile systems or security systems in general, a lot of the information isn't readily available for photos. So you do have to use a bit of artist interpretation for it, but based on the information that we know and the parameters that are set within the ballistic missiles themselves, you are able to make a pretty decent rendering of the missiles. And so this includes anything from the purported distance that the missile is expected to fly. What's really important is that we are able to use this information to either confirm or disprove the information that is on record. And it's really interesting work. I learned this as a student with a simple program like what's called AutoCAD. I believe AutoCAD has a free version of it. So if you're looking at getting into modeling, both Blender and AutoCAD are great programs. One of the things that is nice is that when I learned how to do this, it was a skill that, especially when it comes to women in STEM, oftentimes we're, at least within the US context, there is this idea that women don't get into the sciences and into engineering. But there are tools that we as women have built in. So things where people who do crocheting, we're able to turn objects around in our head so that we know how it should look. And it's the same thing when it comes to this program. So even once I've modeled it, I can turn it around in my head and turn it around in the program and see whether or not the image is rendering correctly or not. So it's a skill that is applicable to any individual that is also free as long as you have a computer that can handle the processing power for the program. And with that, I'll pass it back over to Dave.
Great, thank you. So I mean, I pretty much wrapped up my section of 3D modeling, but you can do a lot of really cool things with it. And then just to go back to a short screen share, let me see if I can do that. Oh, wait, I am messing this up. Sweet. So one of the other fun things you can do with modeling that isn't necessarily as analytically important as what we were just discussing, which is also incredibly important, is just educational value as well. So we created, if you guys want, you can go to NTI or go to Google and type in North Korea missile factory space VR, or I'm sure we can send out a link in a follow-up email after this presentation to the participants. Or if you have a VR headset or a Google Cardboard, or you're just curious, we recreated a missile factory using satellite imagery. And then we had, again, artistic liberties to kind of give you a walking tour of the missiles that North Korea had produced up till 2017, 2018, because that's when this project came out. But you can see them to scale against a 6-foot person, which is really neat, because it's one thing to see an image of a missile in VR or on your screen, but it's another to see it in VR and get into that kind of position where you can almost like feel the missile, kind of get a sense for how big these things are. We see pictures of Kim Jong-un standing next to it, but he's not necessarily the average body type for a person. So getting a sense of scale for how big these missiles are is really important, I think, just for learning, and that's something you can do with this. And then if you're interested in working in AR, which is another thing that you can do using Sketchfab, is you can project the models that we make into surfaces in front of you. So on the 2 images to the left, we have North Korea's hydrogen bomb design that they had shown us. I'm not going to say that it's exactly what they had tested, but it's close enough for engineering purposes and for display. And then to the top right, we have a chemical weapons munition that I think I modeled a long time ago and then was redone by students. So if you're curious about how the mechanism of a binary chemical weapons munition works, you can see that on this image right here. And then just for the wow factor, we took North Korea's nuclear test site in the mountain range form and then projected it onto a table. So we're not quite there yet, but if you have like AR glasses that allow you to see things that are kind of projected in front of you, this would be a really neat way to augment the non-proliferation kind of education field.
Well, thank you so much, everybody, for your presentations. I will drop some of the links in the chat so that way you have access to download some of the programs that I mentioned. These are tools that you don't have to have a technical background to get into. Usually you can just go onto YouTube, search the program, and there are tons and tons of videos. In fact, that's how I learned how to use Blender. There's a guy called Blender Guru. I'll also drop his link for YouTube into the chat that allows for a lot of what I do to be easily accessible to people who will have an interest in this. It kind of democratizes the technology. Oftentimes, a lot of what we talk about is expensive, but in this case, all you need is time and a computer that can handle the processing power of it. Let's get to some of these questions, though. Let's see here. Erin, we have a question for you. I'm going to kind of combine some of them because they're along very similar ideas. How can you become a cybersecurity expert, and are there any organizations that are currently offering any training for this field?
Thank you. Yes, so many good questions. I've tried to respond to some of them by text, but we'll try to do more. There is, in very few universities or places around the world, a specific major or concentration on nuclear cyber systems, right? Very, very rare. So most people who work in the field have computer science or engineering backgrounds. Some people like me have more of a policy background, and we don't do the detailed coding, but we help sort of structure the work. There are a number of training organizations out there. I mentioned in the chat something called the SANS Institute, S-A-N-S. They are expansive. They have a number of both online resources. Many of them are fairly costly. So if you're interested in this field, what I actually recommend is starting off with some of the many resources on the web, podcasts, videos that can be found to sort of test your interest in particular, and then go from there. Any work experience at a critical infrastructure facility connected to computer and digital defense or not even is a really good entry point to work in this field. And getting, educational background in engineering or computer science, those areas, no matter the type of engineering, even, a lot of the systems engineers do really well in the field, but there are chemical engineers who do too, right? So any types of background in that regard. There are also plenty of mathematicians, folks who studied physics, any sorts of background, and then further specialization is a really good place to start.
Thank you. This question here is for Dave. It says, can any of the information transmitted by satellites be hacked so that they won't transmit the appropriate information at the appropriate time?
Yeah, sorry. So I'm not sure if I'm the right person for that, considering we have someone who has more expertise on this information security. But yeah, I mean, I think anything can be hacked. To prevent stuff from getting beamed down, that goes into the digital security of the company providing the imagery data to you. One of the things that I have been hearing certain people from specific countries talk about, especially when it comes to WMD analysis on the open source side of their specific country, is that some people will say, well, how do you know that the data is authentic? So you could go back and use photo forensic software, although that would be a bit of a new realm. The issue with manipulating satellite imagery, though, is that it would have to be done depending on what they're manipulating every time after that event has happened. So example, if the Russians or the North Koreans, or even let's say the Americans want to hide Lake Groom or something, right? Every image from every provider of that site afterwards has to have that gone, or that company loses its reputation for information security and the quality of their product because it is a company and they're making money after its use. And that just seems kind of insurmountable at a certain point. Now, one of the interesting things, though, is that depending on which country you are operating out of and where the image provider's company is based out of, certain sites will be blocked out or digitized to prevent you from seeing them. For example, if you want to look at the French solid fuel production facility to the northeast of Bordeaux, which is there, and you can probably Google it. You get like one or two old images from maybe the late 90s, early 2000s, and then sometime 2 years ago, all the images after that went pixelated. I understand for security reasons, that's the thing. Airbus, if I recall correctly, is a French company, so I get where like the defense industry is going to be like, yeah, you can show whatever you want, but you can't show this. In the same way, there are laws in the United States that prohibit you from buying satellite imagery of Israel at a certain resolution. So you're going to have to fight through a lot of both political and information security kind of concerns. But again, with the way the field is going, while that is a legitimate concern, the potential for competitors to come in and then replace an image provider with more accurate digital mediums is maybe something that's spurring on the information security on that side. Long answer short.
Thank you. Our next question is from Mr. Shaw. It was relating to highlighting threats within 3D printing. I know you touched on it some in your presentation, but if you could share a bit about maybe some other threats that there might be, or ways in which the current field is looking to mitigate those threats.
Yeah, this is the question of sort of mitigating the risks that I described in the presentation and security concerns surrounding 3D printing, is has definitely been discussed, particularly within the multilateral export control regime, such as the Nuclear Suppliers Group Missile and Missile Technology Control Regime, as well as just policy making communities, in addressing non-proliferation issues in general. I wish I could report good news on that front, but to be honest with you, this is an extremely challenging area with respect to finding a clear, definable mitigation measure. It's extremely difficult, and the reasons are that one is that the technology, and particularly its use today, has grown so rapidly and across several industry sectors that it's been really difficult to get cohesion when you have so many different industries, whether it's aerospace or automotive or nuclear, kind of coming together to agree on some sort of maybe common standard or strategy to reduce the risk of 3D printing being exploited for WMD proliferation. And the real concern also is with the computer-aided design files, which can be shared electronically. They're in a digital format. So, if let's say a proliferator has a 3D printer and the right materials, which may be easily acquired and they're dual use, if they can receive or get access to a design file electronically, then that circumvents traditional customs controls, traditional export and import declarations and so forth. It's just accessible from downloading from a cloud or receiving it by email or through a shared drive. So so there are some very real challenges here, but I can say that there's a lot of focus on this space right now, and the mitigation measures are really being focused on strategies to raise awareness among the key sort of, let's say, leaders in the 3D printing space, and particularly those companies offering 3D printing services, so that they can detect, a red flag of, from a new customer, that might indicate that there's some sort of a nefarious use associated with the query. So a lot of work to be done, but awareness raising and outreach seems to be the main focus right now.
Thank you so much for that answer. Next question is for Erin. Can you please kind of explain, like, how do you detect a cyber attack, and what are some of the measures that can be taken against those behind it?
Such an interesting question. So detection of a cyber attack is a multi-step process. I mean, and depends very much on the type of organization you're at, the type of digital system we're talking about. I keep using the email and phishing example because it's something that touches all of us, right? But the reality is that the majority of cyber attacks, the trained computer experts who are ideally at each of these organizations, they're going to defend and push back and detect against the vast majority of them. If they're doing even sort of the basic protocols are in place, the vast majority can be stopped, in part because so many cyber attacks are actually automated attacks. It's not always the case that there's a human on the other side typing a code that then comes directly to your facility or your organization in that split second, right? That can happen, of course. There's what are called advanced persistent threats, or nation state actors who are highly capable, who have teams of coders typing. But what most often happens for those of us, if you're not working on a critical system at the moment, is something automated that's sort of a generic blanket attack that will come through in the hopes that a couple of people out of thousands or hundreds will grant them access. So So there's some low-hanging fruit, as we say, to use that metaphor, that can go really far when it comes to cyber. What can be done against the attacker? Hugely dependent, again, on the context and the type of attack, but this is a very interesting debate, because what historically we understood in a military context as peace and war, or offense and defense, it doesn't really apply when we're talking about these systems. And the proper mode of retaliation sometimes, for example, in current United States doctrine, is to actually go on the offensive. Is a matter of being defensive. The US government calls it defend forward. And there's a huge, broad discussion about if that's not only effective, but if that's appropriate, given all manner of sort of international norms and laws when it comes to battle. So it's a super fascinating question. I could probably talk about it for a really long time with you, but I'll leave it there, and would be happy to follow up by email with anyone who's interested in discussing further.
There's one more question for you as well, Erin. This one relates to cybersecurity and physical security. Specifically, how do you kind of get companies and people who work within, say, the nuclear power field to understand the importance of nuclear security, it's just as important, if not more so, than the physical protection of it, and directly within the context here, the person is asking for developing countries.
Sure. So it's true that for a very long time, nuclear facilities around the world have been focused on physical security. So guards and gates, right? That is no longer enough. I fully agree with the notion that we have to be doing a lot more than just physical security. I'll also just note that in a lot of places around the world, and I'm not an expert on many individual developing countries when it comes to this, but in many places around the world, developing and non-developing countries, the physical security isn't even up to par as it should be, which is one of the other things that you'll see come through in the results of the Nuclear Security Index I mentioned earlier. That's at ntiindex.org if you want to check out the results for your own country there. And that includes physical security protections. Cybersecurity is another, you can use a cyber means to inflict a physical damage of some sort, right? So it is one path towards actually a physical altercation. I talked earlier about the threat of theft of a nuclear material, but we're also concerned about sabotage, which can be done remotely using cyber means. So all of these intersections, I think from an organizational perspective, a lot of operators are really accustomed to thinking about physical security and understand that, but it is more of a discussion that needs to be had around the cybersecurity threats and the extent to which they are just as egregious or just as potentially damaging as the physical security threats in some respects. So it's and potentially more accessible if you don't need to be on site to inflict the pain you intend to inflict, right? So there's a lot more to do there, and every organization has to sort of take the priority on in their own way, make the program work for them, but there has to be, leadership support for it and clear understanding of how damaging this could be from a theft perspective or from a sabotage perspective or from a data integrity or other perspective. So I'd encourage all of you to think about that wherever you work today or tomorrow, and be really an active contributor to bolstering the cyber defenses of wherever you work.
Thank you so much. I'd like to take time to thank our panelists for sharing such important information with us, as well as the attendees who have been joining us these past days. Margarita, we have a couple of hands up in the participants list, but I know that we are also 6 minutes over our time, so I will pass it on to you to decide how we move forward.
Yeah,